Okay, this is question 6 from the January 2011 paper from AQA for Further Pure 1, and we're going to look at how we answer the question. So to start with, the diagram shows a circle C and a line L, which is the tangent to C at the point 1, 1. So the equations of C and L are x squared plus y squared equals 2 and x plus y equals 2 respectively. So all I've done is popped on here the equation of a circle, centre 0. The general equation is x squared plus y squared equals r squared. So comparing that to the equation we're given tells us that r squared is equal to 2, and that means that r is going to be equal to root 2. So I know at the moment that I could label this point here as minus root 2 and root 2, and the same for those ones. So the circle C is now transformed by a stretch with scale factor 2 parallel to the x-axis. The image of C under this stretch is an ellipse E. On the diagram below, sketch the ellipse E, indicating the coordinates of the points where it intersects with the coordinate axes. So, down here, we're going, if we've got a scale factor of 2 parallel to the x-axis, then the y values aren't going to change. So they're going to stay where they are, which at the moment is at root 2 and at minus root 2. So we can leave those there, and we need to leave those labels on because it says we have to indicate the coordinates of the points where it intersects the coordinate axes. So we need those ones, and we're also going to need where it intersects over here. So if we knew from the diagram up here that that's root 2, and we've got a stretch scale factor 2, then it's going to go through at 2 root 2 because we're doubling it. So if we call that 2 root 2 there, and over here we'll have minus 2 root 2. Then we just need to figure out how we're going to sketch our ellipse in. It's going to look a little bit like an eye. Excuse my dodgy drawing. That will do. So that's our sketching the ellipse, indicating the coordinates of the points where it intersects the axis. So we've got all 4 points there, and while it might not be the best drawing in the world, it shows that it's an ellipse and we cover our points, so we're happy. And that's worth 4 marks. Find equation of the ellipse. So up here I've done the general equation of an ellipse, and this is found in the blue formula booklet, is x squared over a squared plus y squared over b squared equals 1. So if we've got that as a general formula, that might help us. But also we know that we're actually starting with this equation of the circle, this x squared plus y squared equals 2, and then we've just transformed it. So if you remember the transformations of graphs chapter, then you should know that if we're doing a stretch with scale factor 2 parallel to the x-axis, that means we're changing the x into some multiple of x. Now the scale factor 2 tells us that the multiple of x is going to be a half x because it's always the reciprocal of this. So we're changing our x to x over 2. So we can now just rewrite our original equation, but instead of having x, we're going to have x over 2. So we had x squared, so we're going to have x over 2, but make sure you do it all squared because it's the original equation said that you had to square the x part. So if we're changing the x for x over 2, we're going to have to square the whole thing. Really important that you don't mix that one up. And then the y hasn't changed and the 2 hasn't changed. So that's the equation of your ellipse sorted. The tangent is slightly more complicated. So let me just show you something useful that I found, which might be helpful. So, if you've got a point P on an ellipse, coordinates x1, y1, then the equation of the ellipse originally was x squared over a squared plus y squared over b squared equals 1. And the equation of the tangent will be x1, so whatever your x coordinate was, x over a squared plus y1, whatever your y coordinate was, y over b squared equals 1. So taking that back to our question means that the tangent to E, this is our equation for E here, so the tangent is going to be this transformed into something along these lines. So we're going to take our coordinates and get rid of the x squared and make it our coordinate times x, and get rid of the y squared and make it our coordinate times y. So in order to do that, I really need that to be in the form x squared over a squared, so I'm going to need to multiply out that thing. So if you don't mind, I'm going to use a whole new sheet of paper, otherwise we're going to run out of space. And I'm going to do it like this. So we had x over 2 all squared plus y squared equals 2. So if we multiply out this bracket, then we get x squared over 2 squared. I'm going to shortcut and put 4. And we've got that there. So our value for a is going to be what? If that is a, and we're comparing that to our original equation, then on the bottom is a squared. So if that's 4, then a is going to be 2, worth knowing, and a squared is 4. And we've got nothing down here, so we can presume that that's a 1. So we're going to say that b and b squared are both equal to 1. So our coordinates given to us in the question were 2, 1. So that's what we're looking for. We're looking for the points 2, 1. And we're going to substitute those into here. So we're going to keep our a squared on the bottom here. And we're going to keep our y squared. So for argument's sake, I'm going to put the 1 in. It doesn't really matter. This x squared is now going to turn into our x coordinate, x, and then the y squared, let's put in our plus, the y squared is going to turn into our y coordinate, which is 1, a lot of y. So if I write that out properly, then we're going to get 2x over 4, which will simplify to x over 2, plus, let's just leave it as y, equals 2. Okay, so that's all they want you to do, 2 marks. It is just have it in the form of x squared over a squared plus y squared over b squared equals something, and then you're going to substitute in, so instead of a squared, x squared, you're going to put in your x coordinate and x, and your y coordinate and y, and then simplify as required. So that's how you find a tangent to an ellipse at the point, and that is all of our question. So that's another 2 marks. So for the top part, we just needed to do sketching the ellipse, so we needed to figure out the radius of the circle, and then we needed to know we were stretching at scale factor 2 parallel to the x-axis. For the second bit, we needed the equation of the ellipse, and you didn't need to do anything complicated there. You just needed to take the original equation and say, what did we do in terms of our transformation? And you need to remember that a stretched scale factor 2 parallel to the x-axis changes your x into a half x, which is the reciprocal of that. So then you just replaced it in your equation, and you're good to go with that one. That would do as an answer. You could also have multiplied out the bracket. Both are acceptable. Tangent, you needed to use this rule, which is just replacing the x squared with x1, which is your coordinate, then x, and replacing the y squared with your y coordinate and y, and then simplifying again as required. So that's question 6 on the January 2011 paper of Further Pure 1. Hopefully that's answered some questions, and if not, then shout.